Good afternoon, ladies and gentlemen. Welcome to the seventh series of our Net Zero Paper Talks. My name is Irdina, and I'll be the master of ceremony for today's event. Thank you, everyone, for joining us today. I would like to also extend a warm welcome to our speaker of the day, Dr. Jaya Rajakal, who will be sharing his insights on his recent academic paper titled Analysis of Current State, Gaps and Opportunities for Technologies in the Malaysian Oil Palm Estates and Palm Oil Mills Towards Net Zero Emission. As mentioned this afternoon, this talk today will be a recurring ARNECC paper talk held on the fourth Thursday every month. Now, the ARNECC Paper Talk is established to provide a broad and dynamic platforms to researchers to share their perspectives on energy climate issues and seeks diverse opportunities to stream climate awareness through scientific approach. Moving on, I would like to introduce to you our moderator for today, Ms. Indira Pratnyaswari. Ms. Indira is currently Associate Research Analyst for the ASEAN Center for Energy. Now, for the next 35 minutes, Ms. Indira will lead this afternoon's discussion as well as introducing our speaker's credential. So without further ado, I would like to pass over the stage to Ms. Indira. Ms. Indira, the stage is yours.
Hi, good day everyone. My name is Indira and I will moderate the discussion session for the rest of this afternoon with Dr. Jaya Prasanth Rajakal, a postdoctoral research fellow at the School of Engineering and Technology from Sunway University, Malaysia. He served as the research lead on various industrial and government agency projects in developing the net zero pathways for Malaysia palm oil, electricity, and oil and gas sectors. His research mainly focusing on system analysis of energy and agro-industrial systems with a focus on developing mathematical optimization models and graphical techniques as decision support tools. So for today's ARNECC Paper Talks, Dr. Jaya will present his recently publications on analysis of current state, gaps, and opportunities for technologies in the Malaysian oil palm estates and palm oil mills towards the net zero emission. At the end of this presentation, we will have an interactive question and answer session, so you can ask your question at the top corner of the box where there is a box for Q&A. So without any further ado, Dr. Jaya, are you ready to present your findings? I think you're still on mute.
Yeah, thank you, Indra. Yep, yes, I'm ready for the talk. Let me share my screen.
Okay, take your time and please welcome Dr. Jaya for the presentation.
I hope my screen is shared now.
Yes, it's shared.
All right, good. Okay, good afternoon, everyone. Thank you for making yourself available for this talk. Appreciate your time. And today, I will be talking about this is actually the talk that I'm going to do is based on our recent project with the Malaysian Palm Oil Council. And as an outcome of this project is the paper that we have recently published based on which the talk is being organized. So, so the talk is on analyzing the current state, gaps and opportunities for technologies in the Malaysian oil palm plantations and mills towards net zero emissions, right? As I said, this is part of a project that we did for the Malaysian Palm Oil Council. So members project, we are a group of researchers from Sunway University and Swinburne who came together, in delivering this project. And a little bit of intro about me. So I'm a postdoc in Sunway University. So basically I do systems analysis of energy and agro-industrial systems with focus on developing mathematical optimization models or graphical tools that act as decision support tools for policymakers in giving recommendations and suggestions. So yeah, okay, without further ado, let me go into the talk. All right, so just to give a brief background to this project, as most of you might know, a lot of countries have been committing net zero targets. So is Malaysia. So Malaysia has set a net zero target by 2050. And the palm oil industry is one of the important sectors in the Malaysian economy, contributing roughly about 5% of GDP. So in order to achieve these net zero targets, so long-term sector-specific decarbonization strategies have been formulated, as to be formulated. So in view of this, that's the premise of this, project where we, when we started, right? And the current scenario, there are a lot of organizations looking into sustainability in the palm oil industry, like the Roundtable Sustainable Palm Oil, the Malaysian Sustainable Palm Oil. So what they basically do is provide standardizations and certifications for palm oil products. But the gap is like there's not much information available for decision makers on the technologies that is available for emission reduction, the capability of the technologies and the cost involved in the technologies and all those things. So that's when we thought, okay, let's do this study. And so the objective of the study was to assess the different pathways within the Malaysian palm oil sector to achieve net zero. Right. So the scope of this work, so we have restricted ourselves to plantation and mills. And within this boundary, so we have initially done the material and energy flow analysis and then estimated the GHG emissions and then reviewed various emission reduction technologies, their capabilities and their associated cost. Right. So as I said, this is a project that we did for the Malaysian Palm Oil Council. So it was a 6-month project that we did from Feb to July last year. So we split the project into 2 phases, phase 1 and phase 2. In phase 1, we focused more on doing a state-of-the-art review and collecting different technologies, their data sets, and also on developing an emission inventory within the considered system boundary. And then we moved on to phase 2, where we assessed each pathways and their capability to achieve net zero. Right. So yeah, so as I said in phase 1, so we did material and energy flow within the system and then developed an emission inventory based on the material and energy flow. And then we reviewed the technologies, as I said, and in phase 2, we evaluated the gaps and opportunities for net zero for each pathway that we have considered. Right. So to begin with, we first analyzed the entire CPO crude palm oil system. Just give me a minute. Yeah. So the various material and energy inputs and outputs into the system. So as you could see, the plantation is the fundamental unit in a palm system. So the various inputs, the fertilizers and the pesticides that is involved in the that is input to the plantations for the crop yield, and also fuels like diesel that are involved in plantation operations. And then the primary product, the FFP from the plantation, is sent to the mill, and the different utilities like power and steam are fed into the mill to process the FFP to produce the crude palm oil as the primary product. In addition to the crude palm oil, various biomass resources like the kernel shell, mesocarp fiber, empty fruit bunch, and the palm oil mill effluent, significant quantities of these are also being generated. So once we have mapped the material and energy flow, we kind of identified the different emission sources within the system. So these are the identified emission sources. So from the fertilizer and pesticide applications and the use of fuels for plantation operations and the use of fuel for power and steam generation at the mill. And also like the degradation of biomass that is being generated if not properly utilized. So these are the different emission sources that we identified. So once we have identified, then we built a simple emission calculator to determine the amount of emissions that is emitted from per ton of CPO production. So this is the user interface, so which runs based on the different data that that runs in the background. So the emission factors is one of the key data that that the interface, the calculator uses to estimate the emissions. So in order to estimate the emissions, so we have considered a baseline scenario. So what is the amount of input that is gone into the plantations and the output of biomass that is produced from the mill. So of course there are variations based on plantations to plantations and mills to mills, but based on our interactions with the different industry stakeholders in the Malaysian palm oil sector, so we came up with a baseline scenario of the amount and the kind of fertilizers that is being applied to the plantations, and then the amount of electricity and the steam that is being input to the mill, and then the quantity of biomass that is generated at the mills. So with this baseline scenario, so we then set into estimating the baseline emissions for producing per ton of CPO. So what we found out was like, so the baseline emissions come to around 3,579 kg CO2 per ton of CPO. But I would like to note that this is not indicative of the Malaysian palm oil industry. So this is just the baseline emissions. However, the Malaysian industry have already employed certain technologies, which I would discuss in the forthcoming slides. But in a baseline scenario where this is the amount of inputs and outputs to the system and no technologies that is being employed, and this is the emission value that that we estimated. So the distribution of emissions is about around 5.3% is from the use of fertilizers and pesticides, and around 3% is from the use of energy for plantation operations, and around 32% from decay of biomass generated at the mill, and 38.6% from the degradation of the palm oil mill effluent, and around 21% from the use of energy for power and steam generation for the mill operations. Right. So yeah. So for the baseline emissions, yeah. So this is the average baseline emissions for Malaysia. So this baseline emissions is a function of the productivity of at the plantation and the mill. So since it is kg CO2 per ton of CPO, so it is the baseline emissions is also a function of the productivity at the mills and the plantations. So we also set into finding baseline emissions for each state in Malaysia. So we could find that across Malaysia, we could see a plus or minus 5% difference in the state level baseline emissions when we compared with the average baseline emissions for the entire country. So yeah, so once we know the baseline emissions and based on the total CPO production, we could also estimate the total annual baseline emissions from the plantation and mills. Right. So this is the distribution of the total emissions across the different states in Malaysia. So you could see that the eastern part of Malaysia, which is part of the Borneo Islands, contribute around 50%, and the Peninsula Malaysia, contribute roughly around 50% of the total emissions. All right. So once we have estimated the emissions, so then the next process is to review the different technologies that are available for the emission reduction. So we since we have looking at a lot of biomass that is being generated both at the plantation and mill, so we set into reviewing different biomass conversion technologies. So we have considered pyrolysis, gasification, composting, fermentation, anaerobic digestion, and briquetting and pelletization, and then CHP systems. So once we have the technologies, then we did set into data collection. So we have to gather a different range of data. So this is the process data of each technologies. So what is the amount of process energy required by each technologies in terms of electricity, in terms of steam, and what is the conversion factor of the technologies from the raw material to the final output product. So this is the process data that we gathered, and then the cost data set, the cost of each technologies, the capital and the operation cost. And then we set into estimating the emission reduction capabilities for each technologies. So yeah, so we basically estimated the capability by estimating the mitigations, emission mitigations from the products that would probably substitute any fossil-based source, plus the emission avoidance from possible like degradation or other things. And we also accounted for the secondary emissions. So during the biomass technologies, they do consume some power and steam, and they those result in GHG emissions. So we have accounted in as that as well. So this is the emission reduction that we have estimated for each technologies. So we have estimated the reduction per ton of FFP, since FFP is, we have taken FFP as the functional unit. So we have benchmarked the emission reduction for per ton of FFP. So I'm not going deep into the data that we have collected, but I would be happy to answer any questions if you have any questions in particular to any of these data sets. Right. So once we have reviewed the technologies, then we analyze the current status of technology implementations in the Malaysian palm oil sector. So we could normally see that the oil palm fronds, which are which are pruned on a monthly basis in the plantation, they are being mulched in the plantation itself, so which acts as a nutrient recycling, thereby reducing the uptake of chemical fertilizers. And then the mesocarp fiber and the palm kernel shell, which is being generated at the palm oil mills. So generally the fiber and the shell have been used in the CHP system within the mill to meet the process energy requirements, the power and steam requirements. And the excess kernel shell is typically transported to a nearby thermal power station where it is co-fired with coal for power. Certain cases, the PK is also exported to other Asian markets like in Korea and Japan. And finally, the palm oil mill effluent. Of late, there is an uptake of installation of biogas units where the mill effluent is anaerobically digested and the biogas is produced, and then which is used to generate power. So these are the current technology implementations in the Malaysian palm oil mills and plantations. So as I said, so the baseline emissions, as we estimated before, it's around 3,579 kg CO2 per ton of CPO. So based on the current the implementation of the adoption of the technologies, we could see that around 68.8% of the baseline emissions have been reduced, have been mitigated. So which comes to around the current emission levels in the Malaysian palm oil sector is around 1,121 kg CO2 per ton of CPO. So this is the current emission levels in the Malaysian palm oil industry, accounting for the implementation of the CHP system, the biogas system, and the other PKs being also used for power generation in other biomass thermal power stations. All right. So so now moving forward, so this we moved into the phase 2 now, where like we assessed different pathways towards net zero. So this is the, as I said, is the current technology implementation in the mill. And what we found out was the empty food punch, the biomass is something that is not being properly utilized at the mills, and it is often being mulched or just disposed, resulting in degradation and methane emissions and all those stuff. So we particularly looked into how can we utilize the AFP biomass. So we looked into different pathways of utilizing the AFP. Right. So the first one we looked into is the briquette pathway, and we could, based on the emission reduction capability that we estimated previously. So based on the analysis, we could see that the briquette pathway actually exceeds the net zero more than 19% of the baseline emissions. So that was something interesting that we figured out, that the briquette pathway is something, it not just achieves net zero, but also exceeds net zero and can has the potential to also, provide credits to other sectors, hard to abate sectors. And looking at the pellet pathway, and Similarly, we could see even the pellet pathway exceeded the net zero emissions marginally by 1.5%. And then moving into fermentation of EFB producing ethanol. However, this pathway, like, there was a gap of around 6.85% to achieving net zero. And similarly, the biofertilizer pathway again falls short of net zero target by 13.6%. And then the syngas pathway, where the EFP is gasified, and then the syngas produced is for used for power generation. Again, here there is a gap in achieving net zero by 1.6 percentage. And then finally, we also looked at pyrolysis of EFB, where the biochar can be used for soil carbon sequestration. You can also see there is a gap, but it's just a marginal gap of 0.41 percentage of the baseline emissions. Right. So in summary, so based on this scenario one, so we could see that the briquette and pellet pathways achieved and in fact exceeded the net zero status, whereas the other pathways they fall short. But the pyrolysis pathway in fact was marginally falling short of the net zero status. Right. So apart from this, we also looked at another scenario two, where we found that the PKS, in scenario one, the scenario was like excess PKS is transported to a nearby thermal power station. But in scenario two, what we have assumed is assuming that all the PKS, even the excess, is fed into the CHP system in the mill, and all the power and the steam, the excess power and the steam is used for as process to meet the process energy requirements for EFP management. So under this scenario, like we wanted to analyze how the pathway assessments look like. So interestingly, there we could see that there are certain pathways where there was an improvement in the emission reduction, but there are certain pathways we could find that there was decrease in the emission reduction compared to scenario one. So if you could see in briquette pathway that there was a reduction in emission reduction capability compared to scenario one, whereas in pellet there was an increase. So basically, it all boils down like when the PKS is directly co-fired in certain pathways, it resulted in a better emission reduction capability compared, to these pathways. That's where the difference lies, right? And also in scenario two, we could see also that the pyrolysis pathway, which was marginally falling short of net zero, but in scenario two, it marginally exceeded net zero status, right? So then we just to, when we talk to industry, we just wanted to give them a case study. So we took a 60 ton per hour palm oil mill, and then the total emissions comes to around 1,500 tons of CO2 per year. And then we analyzed the different pathways in terms of the net cost of emission reduction. So as I said, mulching and CHP and anaerobic digestions are already being existing in most of the mills and plantations. So and then with respect to the other pathways, so we could see that for the briquette pathway, in fact, then there is a negative net cost of emission reduction, which indicates that in fact the pathway is generating revenue in addition to achieving the net zero target. And with respect to with respect to the pellet pathway, again we could see a negative net cost, which indicates revenue being generated in addition to the net zero status. With respect to the ferment ethanol EFP ethanol pathway, there is a positive cost. So this is a cost incurring pathway. And similarly for composting, again it is a cost incurring pathway. And gasification, interestingly, it generates revenue, but it falls short marginally falls short of achieving the net zero status. Right, and with respect to the pyrolysis pathway, it do achieves the net zero target, but it is a cost incurring pathway. Right. So in conclusion, so when we analyze the different pathways, so we ask two questions: as the pathway achieve net zero, and does the pathway generate revenue? So both the briquette and pellet pathways, in both the scenarios, so they have generated, they have achieved net zero status, and are also um, revenue generating pathways, while the fermentation, the ethanol producing, and the biofertilizer pathways, they neither reach net zero or neither revenue generating. Interestingly, in gasification, as I said, it generates revenue, but it falls short in achieving the net zero target. Whereas vice versa, in terms of pyrolysis, it achieves marginally the net zero target, but it is a cost incurring pathway. So this is a kind of conclusion that we made based on our analysis, and and based on this, we gave several recommendations and suggestions to the Malaysian Palm Oil Council and other involved stakeholders. All right, so that's it from me. Thank you for your patient listening, and I'll be happy to take your questions or and other questions. Yeah.
Okay, great. Thank you, Dr. Jaya, for your very clear presentation. Actually, it is very clear and also very comprehensive. And you also, what I like about this presentation is it comprehensively involve all the sectors and also completed with an illustration. So us that is new to this sector, to the palm oil sector, have more like description about the process itself. So everyone, I would like to remind you, if you have any question, you can just type your question on our Q&A box at the upper side of the presentation. So to begin with, I will actually I have a question regarding the background itself. So can you hear me clearly?
Yeah. Okay.
Okay. So my question is, at the first place, why did you choose the upstream and midstream process for this research study, and how effective will the emission reduction will be if compared to the downstream process?
All right. So why did we choose upstream and midstream and not include the downstream? Right. So the CPO, right? So once it is produced, there are various downstream applications, like it goes to different oleochemical industries, in cosmetic products, in food products. So the downstream sector is so huge, and given the time limitations and the project limitations, so we restricted ourselves to the upstream and midstream. And moreover, like generally, like in Malaysia, right, so we produce the crude palm oil, and then it is exported as CPO to the export destinations, where it is being refined to palm oil or different products. So mostly the boundary within Malaysia is up to CPO, and then it is being exported to different countries where it goes to refinery and different downstream activities. That is also one of the reasons that we restricted ourselves. And in terms of emission reduction capabilities for downstream, for now, I don't have any insights or values with it, because the downstream segment is quite diversified, involving different chemicals for refining, and all those things. So all these things have to be accounted for. So generally, the plantation and the mill is viewed as more of a palm oil sector in Malaysia. So that's why we looked into it and focused on that part.
Okay, okay. It's very clear from my side. I think the Q&A part is not working. So for everyone, if you have any question, just type right onto the chat box, and then we will answer it live. So Dr. Jaya, we already have one question here from Mr. Barwia. He asked about if you work with power utilities and the oil and gas sector to combine all of these solutions with carbon capture, you could achieve negative emissions. Is this something you would consider studying in the future? Many thanks. Thank you for
Obviously,
your
yes.
question.
Yeah, certainly yes. I mean, it's something that we are already working on. since the emissions generated, like the biomass are considered biogenic emissions, so we capture that. And then Malaysia has a significant offshore CO2 storage sites. So that is something that we are currently looking at. How can we capture the biogenic emissions from these biomass processes, transport it to the nearby port, and then to the offshore location and store the CO2 is something that we're looking at. Technically feasible, that is what that we have currently, found out. But how far that is economically feasible is something that we are still working on. Maybe 3-4 months down the line, once that part of the study is done, then I could give a clear indication. But yes, certainly the prospect is there, the technical feasibility is there, but the financial feasibility of capturing CO2 and then transporting and storing has to be looked into.
Yeah, I think it is also a great answer because I remember that you previously mentioned that you also undergoing a study with a collaboration between carbon capture technologies and also the bioenergy sites. And I think it related to my second questions. It is
Okay.
about the cost and benefits for different technologies. Well, in your conclusion, you mentioned that those collaboration of technologies might or might not achieve net zero. But in economically, what is the most feasible technologies that will be implemented in the near future? And how is the Malaysian government deal with the maybe huge investment of the bioenergy related technology?
Okay. Um, well, yeah. So from the presentation, what we could see is like the briquette and the pellet pathway, like they are more a revenue generating pathway. But not to say the other pathways are not revenue generating. So the analysis that we have done is more about considering that these technologies are, are adapted or implemented in each specific palm oil mill. So in order for these technologies to, be a more revenue generating technologies, we have to account for the economics of scale. So that's where, like, we have to make sure there is a more centralized biorefinery where we collect all this biomass and, make sure that the economics of scale makes the project a more viable project. And actually, the Malaysian government is also looking something into it. So they have recently released the National Biomass Action Plan, where they have the government is also intending to kind of form or develop biomass palm oil mill clusters. So they develop clusters of palm oil mills, they cluster the mills, and for each cluster, they would set up a biorefinery where the adjoining all the mills would supply the biomass, and then the biorefinery would produce different products. So that's one way that the government is trying to build an economics of scale so that these technologies is also financially viable. Yeah. But as of
Okay.
now, if the technologies have to be installed in each individual mill, then the briquette and the pellet pathway, looks more financially attractive. Yeah.
Okay, thank you, Dr. Jaya, for your answer. So we have another question from Mr. Alam here. He's wondering regarding the unit that you use, which kilogram carbon dioxide or ton CO2, not ton CO2 equivalent. Is it also only calculating the CO2 or other greenhouse gas emission as well?
Right. So yeah, we are considering other greenhouse gases. It should be ton CO2 equivalent. Yeah, there is discrepancy in the unit of notation. So we have also included methane emissions from POME. So it has to be kg CO2 equivalent. Yeah.
Okay, Mr. Alam, I hope that answer your question or any follow-up question from your side. Okay, we have another question. What is your from Mr. W? How's your opinion about prospects of palm oil in Malaysia compared to other country like Indonesia, and how the government in Malaysia support the technology in terms of palm oil productivity?
Uh, maybe I'm not well placed in a position to compare Malaysian palm oil with the other countries, since I don't know the policy framework in other countries. But what I can say about the Malaysian sector is like there have been series of initiatives being taken over a decade or more. Like around 2015, there was a feed-in tariff scheme which the government introduced, which kind of pushed all the mills to utilize their kernel shell and fiber to produce electricity and feed into the grid. And then recently, there is also a policy push towards biogas installation in mills. Um, if I'm if I'm right, the government is, in order to renew any expansion of mills or renew new policy, they are looking at installation of biogas units. So there are some policy push here and there, which is, which has allowed a greater integration of these technologies into the sector. Definitely, the industry, the palm oil sector, has potential in other countries as well, especially in Indonesia, because the biomass generated is the same. So, if not in Indonesia, since the industry is huge, the biomass production should also be higher. So, it's about how do we, encourage the industries to implement such technologies. Obviously, like incentives, tax breaks or something, common, things that can be done. But I'm really not sure what are the, nitty gritties in the Indonesian palm oil sector, so I will not be able to comment on that. But yeah, over the decades, there has been a series of initiatives from the Malaysian side, so that's allowed a greater implementation, especially of the CHP system and the biogas system in Malaysia.
Okay, thank you very much for your answer. I think we still have much time to have discussion. So if any one of you still have question, you are very welcome to type your question to the our chat box. Maybe another follow-up question from me. So as I know that um, EU, the European Union, is having this kind of banning the import of palm oils to the EU from Malaysia and also Indonesia. Um, from your perspective, are your research is also navigating to improve the technology just to cope with those EU regulations, or do you have any uh, relations to this kind of regulation that you just regulated for the export or import of the palm oil industry?
Well, I mean, the premise of this work is also part of the, restrictions, imposed by EU. I mean, we do understand that, of course, palm oil is a highly productive crop, and in order to meet the edible oil demand, it is the crucial crop to ensure food security. At the same time, we also, need to address the concerns from, our importing partners. So this study is also partly a way, to really demonstrate, to the partners that, what the palm oil industry is capable of, and how, we can achieve net zero, and, the product is more sustainable. So of course, MPOC, like we would be soon releasing as a book launch of our report. So we would possibly also, invite delegates from them, where we would disseminate our findings to them, so that we could have a greater acceptance of our products in their market. Yeah.
Yeah, exactly, exactly. That I think that it is a good step for us, in especially in ASEAN, to consider like low carbon technologies to be implemented in our industry, so that we can have like wider market to approach with our product. So we still have several questions here. The next question is from Dr. Naesh. So from CNG Analytica Malaysia. He's asking about your model is taking technology parameter as main variable in the model. However, he thinks that the model also should take into consideration other parameters such as agriculture, practices, land use, and as well as supply chain emissions factors. So maybe you have thoughts on this, Dr. Jaya?
Yep. Yep. I fully agree. Like we have not considered the transport and the supply chain part of this. We have just evaluated the technologies as such. Certainly, like when we include assuming that the biomass is processed in a different facility away from the mill, there would be transport emissions involved. And then, yeah, so that component is there. With respect to the land use change emissions, according to the recent MSPO 2.0 guideline, so they have set a deforestation cutoff date of 2019 December. So considering that, so most of all the plantations in Malaysia are are being developed prior to that. So we are considering that the land use emissions are not part of it. So considering, because we consider the standardization. Yeah. Of course, there are different factors that we can account. The agriculture practices, the fertilizers, or the other things that are add on from what we have considered. We can include case by case. That's why we have accounted the emission. We have developed the emission calculator, so the user themselves can key in the amount of fertilizer they are applying and the amount of diesel they are using, all those things that would result maybe in a different baseline emissions. Yeah.
Okay, great. I think the idea of establishing the emission calculator is very interesting yet simple idea that could be distributed to other industries as well to make it more efficient, I think, to calculate their greenhouse gas emissions based on each type of production. So I think we still have two questions left from Idam Shukar. The first one is, do you consider a mixed pathway that can achieve both net zero and plus revenue? And the second question is, from your perspectives, what other policies that the government should introduce to support this effort? And can this project stand without the current electricity tariff or energy subsidy? That's a good question.
Indra, can you come again for the first question?
Oh,
I lost a
the
bit.
first question is, do you consider a mixed pathway that can achieve both net zero and revenue?
Technically, yes. So the industry wouldn't get into any pathway that is not revenue generating for them. So as per our analysis, yeah, briquette and pellet are both net zero and revenue generating pathways. So as I answered previously, in order for other pathways to be revenue generating, we have to account for economics of scale, where we have to cluster the mills and centralize all the biomass so that we can build economics of scale and then make it a more profitable venture. And with respect to your second question on, can you come again? Sorry, your second question.
What other policy that the government should introduce to support this effort? And can this project stand without the current electricity tariff or subsidy?
Okay, so what are the other policies? So if you could see, most of the mills are in kind of, rural places. And in order for them to adopt these technologies, like when they generate power, they need to export to the grid. So in certain mills, we don't have the grid connectivity. So in terms of infrastructure, a lot can be done. And another challenge is the cost. Most of these equipments are being imported, like the steam generating equipments or the biogas equipments are being imported. So maybe the government can bring policies that would boost local manufacturing that could reduce the cost. And especially in terms of biomass supply chain. So I mean, this supply chain level can be done only from when there is a push from the government, because the mills, there are a lot of mills, independent mills. So in order to form clusters, which the government is doing, but how they are going to do is still not sure. So yeah, these are something that could policies that the government can look into in order for greater implementation of the technologies. In For your second part of the question, which is the current tariff sufficient to make this project feasible? As I said, yeah, the analysis that we have done now is based on the current tariff. Interestingly, if the tariff goes high, some of the pathways could become more would become financially feasible quite easily. So yeah, so we only look at a scenario where the prices are going to go up. So I mean the tariff prices. So we are looking at becoming having more and more pathways more economically feasible in that sense lah.
Okay, it's a good answer from your side, and we have one last question from Jenny, I think. Usually, palm oil plantation and processors have biomass power plants to supply their electricity needs. The raw material for this power plant come from palm oil waste itself. What do you think about the carbon dioxide production that may be generated from this power plant?
So can you come again? Sorry, the first part I missed you.
Usually, oil palm plantations and processors have biomass power plants to supply their electricity needs.
Yeah.
The raw material for this power plant comes from palm oil waste itself. What do you think about the carbon dioxide production that may be generated from these power plants?
All right. So biomass-based power generation is considered carbon neutral. So these are called biogenic emissions. Carbon neutral because so when the plant grows during the photosynthesis process, it absorbs CO2 and then it grows, right? And then we harvest the plant and then the biomass part is then used for electricity generation, which is again being emitted. So it is considered carbon neutral, and these type of emissions are called biogenic emissions. So that would not account into the emission since it's carbon neutral. However, like as I mentioned before, we can still capture these biogenic emissions and can utilize for different chemical fuel production or storage, which could result in deep decarbonization. So we are actually going into negative emissions because we are capturing the carbon neutral emissions and then storing it, utilizing it. So that pathway can also be included. So we would go into more negative emissions. Yeah. Hope I made the answer clear.
Okay, thank you. I hope this answered your question, Jenny. So if everyone still have any question, feel free to maybe reach us or through our ARNECC research database or through Dr. Jaya emails itself. So everyone, because we have a really limited time, I will conclude this session into like simple conclusion from my side. So as Dr. Jaya presented his paper on analysis of current state gaps and opportunities for technologies in the Malaysian oil palm estates and palm oil mills towards net zero emissions, we can highlight it that there are two potential technologies that could be adapted in the process of the palm oil industry itself, namely by managing the waste into the briquette and pellet, and also using another technologies. I think it's kind of
Biochar.
bioenergy, right? Yeah,
Biochar.
biochar. But aside from the implementation, we also need political will and also the support from government to implement this technology in a massive way so that the technology could be adapted in a very proper way in order to reduce the greenhouse gases emission. This technology will also have the potential to expand for the implementation of carbon capture and storage for each stage of process of producing the palm oil itself, and also simultaneously implementing regulations about the investment and cost to support the implementation of these low carbon technologies. So everyone, I think that's all from my side. Dr. Jaya, do you have any closing statement before we close this session?
Thank you. It was nicely summarized, Indra. Thank you for that. And thank you for attending the talk. And feel free to connect with me if you have any further questions and also for collaborations. We work currently. I'm working more into analyzing a economic evaluation of palm-based next-gen fuels like hydrogen, ammonia, and e-methanol. And if you are interested in such areas, do connect with me. I'm open for collaborations and joint works. Yeah. Thank you again.
Thank you, Dr. Jaya, and thank you everyone for attending this session. I will get this back to Irdena.
Thank you, Ms. Indira and Dr. Jaya, for a great presentation. Moving on to the next agenda, we would like to have a photo session between our speaker, Dr. Jaya, and our moderator, Ms. Indira. To Dr. Jaya and Ms. Indira, please be ready and give your biggest smile to the camera. Okay, on my count, 1, 2, 3, smile. Okay, another pose. 1, 2, 3, smile. All right, thank you, Dr. Jaya and Ms. Indira. To Dr. Jaya, thank you once again for lending your precious time to be with us today and share the findings on how Malaysia leverage on the technologies to decarbonize the palm oil sector toward net zero emissions. This
My
topic is
pleasure.
indeed this topic is indeed something that worth discussing as Malaysia aspiration in achieving net zero target by 2050 and look into the decarbonization of the palm oil industry. Adding on, we are supporting our upcoming work in constructing the newest rendition of the ASEAN Energy Blueprint and the brand new ASEAN Renewable Energy Long-Term Framework. As we hope the discussion today can be a food for thought for all the audience today, as well as an aid to create a future productive discourse in regards to Malaysia's effort on the greenhouse gases emissions reduction in pursuance of net zero future and unveiling the upstream and midstream of the palm oil sector. Finally, this event has approached its end. Thank you everyone for attending as well as your lively questions. We will see you again in the next episode of ARNECC Paper Talks because a gentle reminder, ARNECC Paper Talk will be held monthly on every fourth Thursday, which means we will meet again next month in June. So stay tuned to our social media, newsletters, and website to obtain more information in regards to ARNECC Paper Talks as well as things related to net zero in Southeast Asia. So I'll bid a goodbye to everyone and have a wonderful afternoon. Bye.
Thank you.